Once we know that the correlation coefficient is significant, we can go on and try to find the equation of the regression line, which is also called least square line, or a line of best fit through the data points. We try to minimize the deviations from the data points that are observed to those predicted on the best fitting line. And this is called the principle of least squares. And this is the drawing in here is the line of best fit. In white I have the observed points, and the predicted points are the points on the line of best fit. And we are trying to minimize the errors epsilon 1, epsilon 2, epsilon I. So we try to minimize the sum of the squares of the deviations. And the line that minimizes the sum of the square of deviations of errors of the observed values yi from the predicted values y hat is what we call the line of best fit. This procedure is complex. It involves differential calculus and is similar to the one used in Intro to Stats to find the standard deviation and variance. And so the individual errors, the sum of the individual errors, we try to combine them, and to avoid cancellation and penalize large errors, we seek a line that minimizes basically the sum of square errors, which is the sum of difference between the observed values yi minus the predicted values y bar and squared. And then instead of y bar, we can substitute the equation of the line of best fit, which is this one. So in trying to minimize that, we come up with a formula for beta 0 hat, which is the y-intercept, and beta 1 hat, which is the slope of the line. And so the formulas for the slope, in most calculators the slope is indicated with B, and this is the sample, we are finding the sample regression line. The slope beta 1 hat is equal to sxy over sxx, or if you prefer, of xy, so the numerator is identical to the numerator of the formula for the regression line. And so it's sum of xy minus fraction line sum of x times sum of y divided by n. Divided basically the numerator of variance, sum of x squared minus sum of x and then squared and then divided by n. Of course there are various formulas, but this is the one that I will be using. And the y-intercept, because the regression line goes through the means x bar and y bar, to find the y-intercept, which in most calculators is indicated with a, but we'll call it beta 0 hat, we need the mean of the y, so y bar minus the slope multiplied by the mean of the x. So these two formulas are important because we use them in order to compute the line of best fit, which has the following expression: y hat, so the predicted y value, equals beta 1 hat times x plus beta 0 hat. And this is the equation of the line of best fit. What happens is that every predicted y value, which is called y hat, is closer to its mean than the corresponding value of x, and this is in standard deviation terms, and so there is a regression to the mean. Just to give you an example, for the absence and grades question, here I am just recalling from the previous example all the sums of x, sum of x squared, n equals 7, sum of y squared, sum of xy. And then I'm finding x bar, which is sum of x, so 57 divided by 7, so it's 8.14, and y bar, which is sum of y divided by n. So once you have a correlation regression data, you should be finding all these and conserve them. And then if we go look at the formula for beta 1 hat, is sum of xy minus sum of x times sum of y over n. So sum of xy is 3745, subtract 57 times 511 and divided by 7. And then the denominator is sum of x squared, or 579, minus sum of x and then squared and then divided by n. So minus 57 squared and then divided by n, or divided by 7. So if I compute the numerator, I will come up with minus 416, and if I compute the denominator, I'll come up with 114.857, etc. And if I divide the two things, I will get minus 3.622. And that's the slope. And then let's now try to find the y-intercept. And so here is the formula for y-intercept. And here is the y bar, x bar, and beta 1 hat from the previous page. So in here, to find the y-intercept, I just substitute, and I will get 73 subtract minus 3.622 times 8.14. So I'll come up with a positive 29.4831, which added to 73 gives me 102.483. And therefore, the equation of the regression line will be y hat equal 102.483 minus 3.622x. So it's a negative correlation, and so the slope is negative, and the slope is not related at all with the correlation coefficient apart the sign, and the equation of the regression line will be helpful to find predictions. Thanks for listening.